All right, so the point of the lesson today is to solve higher degree equations by using factoring, and that means higher than a quadratic, okay? But we will still be working with quadratics at some point in the problem, because what we are going to be doing some of the time, like in this first one, we'll do a GCF at some point, and then we will solve a quadratic. So for this problem right here, we begin by putting it in standard form. By subtracting 3x squared to both sides. And then standard form means you write the exponents in descending order. So the biggest exponent first, then the smaller exponent, then the smallest. So I've got 2x cubed minus 3x squared minus 20x equals 0. And it really feels right here like we could do swing method or grouping or quadratic formula or something. But here's the reason why we can't do that yet. It's because it's not a quadratic. It's a cubic, right? The highest degree is 3. And here's where we want to factor out a greatest common factor. If you look at each of those three terms, 2x cubed, negative 3x squared, and negative 20x, they all have 1x in common. They don't have any factors in the integers, the coefficients in common. If you're looking at just the number pieces, the 2, the negative 3, and the negative 20, they don't have any factors in common, but they all have 1x in common. So we're going to start by taking a GCF of x and factoring it out. So I'm not getting rid of it, by the way. I'm just dividing it out. It's like a reverse distributive. It's like distributive with division. And so because I'm not getting rid of it, I'm keeping it in the problem. I'm just going to write down the GCF of x. And then what's left over when I divide it out of each of those terms, right? It gives me 2x squared minus 3x minus 20. So now if you look at just what's inside the parentheses here, that is a quadratic. You can solve that however you like. I'm going to use the swing method, okay? Because it's the fastest. It is a shortcut. You don't have to use it if you don't like it. You can do grouping here if you prefer grouping. But I like swing method because it makes things go faster. So I'm going to do the swing method, and that starts like this. And it starts the same way as grouping. What multiplies to AC, which is negative 40, and adds to B, which is negative 3. And it's negative 8 and 5. But part of the swing method is dividing by the A value when the A value is not 1. So our A value here is 2. So I'm going to divide both of those things by 2. This is where the shortcut part comes into play. There is a lot of math actually involved in the shortcut, but it's kind of complicated to show. So we're just going to take it on faith that it's okay. And so then what these two numbers do is give me my factors. So this becomes x minus 8 over 2, which is negative 4. And then x plus 5 over 2, because that doesn't simplify. So I'm just going to leave it there. And then this x from this previous step comes down. And then we solve by setting each of the factors equal to 0. And here's what I mean by factors. Remember that factors are things being multiplied. So I have 3 factors here. I have x, I have x minus 4, and I have x plus 5 halves. That's 3 different things. They're all being multiplied together, so they're called factors. This is our factored form. And if all those things being multiplied equals 0, then one or all of them must equal 0, right? Because when you multiply stuff by 0, that's how you get 0. So we just figure out all our possibilities by letting each factor equal 0 and solving for x. You could also do insider's lie here. And for this first one, x equals 0, there's nothing else I can do. For x minus 4 equals 0, we get x equals 4. And x plus 5 halves equals 0 gives us x equals negative 5 halves. So that's our answers for the first one. You can unmute yourself and say if you need this screen up anymore. Otherwise, I'm going to change it. Okay, so this problem right here, you still want to start by putting it in standard form. Which means getting it equal to 0. So I subtract 3x squared from both sides. And I've got x cubed minus 3x squared minus 7x plus 21 equals 0. There are no like terms here, so nothing combines. So it stays in this form. And when you have 4 terms where nothing combines, you automatically know you have to do grouping. So that's going to be our next step. So I'm going to group the first 2 together and the second 2 together. And within grouping, what you do is you take a GCF in both of those groups separately. So looking at the first group, the x cubed minus 3x squared, I look at the coefficients first, meaning the numbers in front of the variables. So this first one, bless you, has a 1. And if you're looking at 1 and -3, you're thinking, well, they don't have any numbers in common, so I'm going to leave them alone. But then when you look at the x's, you're trying to figure out what's the most amount of x's that they both have. And they both have x squared in them. So this is their greatest common factor. And so I divide that out, side of the parentheses. And then leave the quotients inside, or the remainders when you divide it out. So in that first term, when I have x cubed, and I divide out x squared, that leaves me with just x. And then in the second term, x squared, and I divide out x squared, that means there's no x's left. So just got the -3. We do that same process in the second group. What do they have in common? So I'm going to look at the numbers first, the -7 and the 21. They actually, this time, the coefficients, or the number parts, they do have a factor in common. They have 7. And whenever that middle term is negative, you want to make your GCF negative. And I'll talk about that again in just a second. And then you look at their x's to see what they have in common, and they actually don't have any in common. 21 has no x's on it, so they have none in common, so we're not going to divide anything out. So we go straight to the next step. The -7 was the GCF for that group. And I'm going to put the leftovers in parentheses. So -7 divided by -7 is +1x. I didn't write the 1 though, because we don't have to. And then 21 divided by -7 is -3. And right here, I just want to take small second to talk about, this is the reason why we divided a negative number out from the second group. Whenever this is negative, this sign that I just highlighted yellow, you want your GCF to be negative, because imagine you did distributive property right here to check your work. You would have -7 times x, so -7x, which is what we had. And then -7 times -3 is +21, which is what we had just above. So that's the importance of being careful with your negatives. Because now we have x minus 3 matching in both of these groups. X minus 3 here and x minus 3 here. So now we think of taking that group, that x minus 3, and considering that as a GCF now, right? If we divide that out of both groups, we would have our GCF out here, the leftovers in parentheses. And in the first group, when I take x minus 3 out, I'm left with the x squared. And in the second group, when I factor out the x minus 3, I'm left with -7. I'm just factoring it out, the x minus 3. Just in the same way I factored out x squared in the... Oh, sure. You don't like the divide by x minus 3 step? That's no problem. I just do it for like people who it's visually helpful for them, but you don't have to write that, no. And so then the last step, so now we have our factored form. I have two factors. I have the x minus 3 is one, right? Because factors are things being multiplied. So this is one factor. This whole thing is a second factor. So two factors. We are going to set them individually equal to 0. So let your factors equal 0. So this one. And this problem explains one of the reasons why I don't do a lot of talking about insider's lie, because insider's lie only works for linear factors. So if you see that yellow factor, it has a degree of 1. And you can use insider's lie on that and you're good. But insider's lie would fail you on the blue factor, the x squared minus 7, because you would think, oh, okay, 7. That's my answer. But it doesn't work here. So this is a quadratic. So we solve that by adding 7 to both sides. And then doing, guess what here? Square rooting. And getting x equals square root of 7. And don't forget also it's a plus or minus the square root of 7. So we have 3 answers here. Because when you take a square root of an equation, both the plus and negative versions would satisfy if you plugged it back in here. It's the square root property from the last unit. And we knew we were going to get 3 solutions because the degree of the original problem was 3. So we have plus or minus rad 7 is 2 answers, and then x equals 3 is the third answer. This one right here, I need you to think about how many answers this is going to have. You can tell just by looking how many answers. Okay, now I can see all your faces. Show me with your fingers how many answers is this going to have. No one showed you with your fingers. Seriously, y'all, you'd think you were over school being done in Zoom or something. Thank you. I mean, I am over Zoom school. I get it. 4, right? So, thank you. So, or maybe it's just Monday. Or maybe it's all of the above. It's everything. It's everything. I'm tired of everything. So x to the 4 minus 16 equals 0. There's going to be 4 answers. But let me show you what most students give me for this problem. Okay? They look at it, and they see 16, and they see x with an even power, and they do this. They add 16 to both sides, which is a good beginning. It's actually how I'm going to start. I'm not even going to erase that. We're going to keep it. We're going to isolate the exponent term. And then we square root both sides. Most people get that okay. Square root. And then they do this. And this is where they fail. Their method fails. They say x equals plus or minus 4. And they box their answer and they go on about their lives. Exactly. Perfect. And so this is not the stopping point of the problem. Because when you take the square root of x to the 4 on the left, you get x squared. And when you get x squared, you have to understand you're not done, right? There is more work to do. You will keep going until you get to a spot where x is no longer squared. And so what you want to do at this step is make your plus or minus version. You have x squared equals 4, and x squared could also equal negative 4. So we make those two separate equations. And then guess what we're going to do with those two? We're going to square root again. So on the left, when we do square root again, now we have just x on the left. And it's going to be positive or negative, whatever the square root of 4 is, which is 2. And then in the right equation, the right side, not correct, but like on the right, I'm going to square root again. And that gives me x equals positive, negative. But just here you have to remember about I, because it's negative 1 times 4 under the square root. So the square root of 4 is 2, and the square root of negative 1 is I. And so how many solutions is that? 4. You have plus 2, minus 2, plus 2i, and minus 2i. And if you remember, okay, so what I'm about to tell you, you don't even have to listen if you don't want another thing in your brain. You can kind of zone me out for a second. But if you like the difference of squares, which we haven't talked about explicitly because I wanted you to have as little things to remember as possible. So if you don't want another thing to remember, don't listen. But if you're a perfect square person, like I'm a perfect square person, what you could have done here is said that this is x squared minus 4 times x squared plus 4. This is difference of 2 squares. And then just set those two factors equal to 0 and solved. And you would get the same thing. Most of my students do this method on the left with the square rooting. So I just switched over my teaching to that because that's usually where people start. But this is my preferred method. And it might be yours. That's called perfect squares, but I was just showing that because you don't have to remember the extra thing. Oh, the one I just did? Just square root property. Just taking square roots of both sides, you're basically just doing it twice. So do this problem on your own. Please put your answer in the chat. as you finish. While you're working on that, I'm going to put attendance in, but I will be keeping my eye on the chat too. And if you're watching the video asynchronously, pause and try this problem before you unpause. Okay, so I'm going to go through this pretty quickly because probably you're done and probably you're good. So here is the work. Standard form first. By moving the 9x and the 2x squared to the left. And then here you would need to look if anything combines, because that would change your next step probably. And nothing does. So we have 4 terms, which means we go to grouping. And the first group has a GCF of x squared, which I'm going to factor out. The second group has a GCF of -9. So that leaves me x squared times x plus 2 minus 9 times x plus 2 equals 0. So now when you look at the two groups compared to each other, they have a GCF of x plus 2, which I'm going to factor out. And that will give me x plus 2 as a GCF, and then x squared minus 9 left afterwards. Set your factors equal to 0. So x plus 2 equals 0. X squared minus 9 equals 0. Math, math, math. Square root both sides. X equals positive negative square root of 9, which simplifies to positive negative 3. Oh, hold on, you guys. I feel like I did something wrong. No, I didn't do anything wrong. All right, there you go. Let me see. Tell you when